Hi, let's get started with our new section. And this video, I will talk about GAN, which is a generative adversarial network. So let's write some text for that. So this is an introduction to GAN, which is the generative adversarial network. So GAN is becoming more and more popular in recent years, and GAN are intuitively understood and using the case of counterfeiter, which is the generator, and the police, which is the discriminator. So initially, the counterfeiter shows the police fake money, and then the police identify it as fake and explain to the counterfeiter why it is fake. So the counterfeiter makes new fake money based on the feedback it received. The police finds it fake and informs the counterfeiter why it is fake. So the process repeat. Several amount of time until the counterfeiter will be able to make fake money, which the police will not be able to recognize that. So GAN is a combination of a Fogger network and an expert network. Each being trained to beat the other. So the generator network takes a random vector as input and generates a synthetic image. The discriminator network takes an input image and predict whether the image is real or fake. So we pass the discriminator network either a real or fake image. So the generator network is trained to produce images and fool the discriminator network into believing that they are real. The discriminator network is also constantly improving at not getting fooled. As we pass the feedback while we train it. And training GAN is very challenging. So now let's talk about the generator network. So generator network. So in here, the generator network, the generator network takes a random vector of fixed dimension as input and apply a set of transpose convolution, batch normalization, and ReLU activation to it and generates an image of the required size. Now let's talk about the transpose convolution. So what is transpose convolutions. So transpose convolution are also called the fractionally straight convolutions. They work in the opposite way to how convolution works. Now is the time to talk about batch normalization. So need more space. So batch normalization. So the value so when all the features are being passed to either machine learning or deep learning algorithm are normalized. That is the values of the feature are centered to 0 by subtracting the mean from the data and giving the data a unit until standard deviation by dividing the data by its standard deviation. So we have the library, which is touch vision dot normalize method in PyTorch to handle that. So batch normalization act like an intermediate function or a layer which normalize the intermediate data when the mean and variance are changing over time during training. So batch normalization behave differently during the training, validation, and testing. So during training, the mean and variance is calculated for the data in batch for both validation and testing. The global values are used to sum up the main key is that the main key to remember that it normalize the intermediate data. So there are several advantages by using the batch normalization. So the first one is improve the gradient flow through the network. So it help us to build the deeper network. So the second advantage is it allow higher learning rate. The third one is it reduces the strong dependency of initialization. And the last one is it acts as a form of regularization and reduce the dependency of dropout. So most of modern architecture network such as ResNet and Inception will use its batch normalization extensively. And that is all in this introduction video. So I hope you enjoy it. So in this course, I don't go deeper. I don't go deep into the ResNet. So in this course, I will not go deep into RedNet and Inception. If you want to learn, you can take my deep learning course for that. So, and that is all in this introduction video. So I hope you enjoy it, and I will see you in the next video.